look at first, let's take a look on the back. This is the very last page of your notes. I want to wrap up with a truth table of the conditional. Remember we said our conditional at the very end of class was an if-then statement. So that's what I've got here. So let's take a look at this. We're going to do it in the same way that we did the other ones. We're going to assume all of our different cases. They're both true. The first one is false and the second one is true, or true then false, or false then false. The most important thing that you need to know about a conditional is the only way to make it false is if only my conclusion is false. And let me show you why. So I'm going to use an example of the conditional statement if it is sunny, if it is sunny, then I will wear my sunglasses. So it is sunny is my P. My Q will wear my sunglasses. That's my conclusion, because I'm basically saying, I am saying that if it's sunny out, the conclusion is I'll wear my sunglasses. So we can go through it. I think it's pretty self-explanatory that one's going to be true. That one makes sense. Things get a little bit fuzzier here with the middle two. I need to keep referring back to my original conditional though. My original conditional, again, if it's sunny, then I'm going to wear my sunglasses. This is telling me that actually that first part is false. So it's not sunny out. It's not sunny out, then I will wear my sunglasses. The reason that I'm still going to say that statement is true, even if it is not sunny, is because that has no effect on my conclusion. I might just be wearing my sunglasses because I like them. It doesn't really matter if it's sunny or not. It's not going to affect, it doesn't affect my outcome. So I'm still going to say that statement is true. I'm going to think about the second one in the same way, and I will show you. And this is the one where it kind of makes more sense, because if I say, okay, never mind, P is true and Q is false, and again, I'm looking at this one right here. So if I say it is sunny, but I'm not going to wear my sunglasses, it makes the whole statement false, because the whole original conditional, the whole point of it was saying, if it is sunny, I conclude that I'm going to wear my sunglasses. So if my conclusion completely changes, there's no way I can say that conditional is true. It would have to be false if my conclusion changes. Think about it if I'm thinking about this last one in the same way, they're both false. You'll see this is one, you guys were saying, oh, well, if I've got two negatives, it's a positive. That is kind of true for a conditional. Because it's saying, my first statement's false, so okay, it's not sunny. If it's not sunny, then I'm not wearing my sunglasses. That checks out when I put it up against my original statement. Because my original one's saying, if it is sunny, then I will wear them. But if I come down here and I say, well, if it's not sunny, then I won't wear them. That makes perfect sense. There's no kind of holes in that argument, I guess. So I'm going to say, yep, that checks out, still true. Don't worry too much about that. We will talk a little bit more about how to make this truth table, and we're not going to focus too much on truth tables, because especially with a conditional, I think it is probably easier to just kind of talk it out and think about it rather than trying to do something from a truth table. So let's move on. We want to talk about logical equivalence. So let's actually flip back to the front page. And I've written some stuff on here already. We talked about conditionals at the end of class, and we just talked about them. There are 3 other things in relation to a conditional that I want to talk about, that we're going to use to build arguments, to determine if things are true, all that good stuff. The first one is converse. All of this formed by example. It tells you, it gives you an example. Like I said, they're all based off your conditional. It starts with a conditional, and then it switches it up in all of these examples to match up with what definition we're looking at. So if I've got converse, that is just saying that I'm flipping my P and my Q. Flipping my hypothesis and my conclusion. A way that we can remember that is, and I stole this from another teacher, converse have laces, so we switch the places. Because that's just what we did here. We switched our places of our P and Q. So there's that. The next one that's easy to remember, I think, is the contrapositive, because it is the ugliest and the longest word, and it is also the most work for us, because I have to flip both of those, and then I have to negate them. So I'm going to say not Q, then not P. So that works. And then the only other one, the inverse, I don't have a good way for you to remember that, really. All you got to do is negate each of them. You maintain order, but you negate. I'll think about maybe a good way that we can use to remember that. Or you can. Okay, so let's go back to the back page and talk about this logically equivalent stuff. The reason I needed to do that first is because we're going to use some of those words in here. So logically equivalent means they have the same truth value. So, the conditional and the contrapositive are logically equivalent, as are the converse and the inverse. So both of our verses are logically equivalent, and both of the other 2 are logically equivalent to each other as well. So let's take a look what all of this stuff means, the converse, inverse, all this good stuff. So I've got this. Lions are cats that can roar. And what they did here is we talked a little bit about this, we turned it into a conditional statement, because this is going to be my baseline for any of this. So it says, if an animal is a lion, then it is a cat that can roar. These are easiest to think about in terms of what you are actually saying. So I'm saying I am an animal that's a lion, then it is a cat that can roar. That's true. Because I know that that's a quality that lions have. They're cats that can roar. So if I know something's a lion, then I know it's a cat that can roar. Converse, they flipped it around. They said if an animal is a cat that can roar, it is a lion. Now that's not necessarily true. And that's kind of where I can start thinking about things like counterexamples and those types of things. Because if I say, I've got a tiger can roar, it's not necessarily a lion. So I'm going to say that this is false. Move down to inverse. If an animal is not a lion, then it is not a cat that can roar. I'm using the same logic there. I've got an animal that's not a lion. They're basically saying, well, then it's no way that it's not a cat that can roar. Again, I got myself a tiger. That's a cat that can roar, and it's not a lion. So my inverse is also false. And then the last one, contrapositive. If an animal is not a cat that can roar, then it is not a lion. That one is also going to be true. Because, like I said, we know that a quality that lions have is that they're cats that can roar. So if I've got an animal that is not a cat that can roar, there's no way it can be a lion. It doesn't have those qualities. So that checks out as well, and that's true. And as you can see, what we said up top, we said that my conditional and my contrapositive are going to have the same truth value, and my converse and my inverse have the same truth value. Both, in this case, both my conditional and contrapositive are true, my converse and inverse are false. Let's move on to this last piece real quick, biconditionals. Let's do this definition first. Biconditional. It is a conjunction of a conditional statement and its converse. Okay? A key word for doing a biconditional, the way you know that's what you're looking at, is the keywords if and only if. And abbreviated, you're going to see it as IFF. So let's see, let's break it down. They said it's a conjunction of our conditional and our and a converse. So let's take our biconditional right here and let's break it down. I've got an angle is a right angle if and only if its measure is 90 degrees. Okay? My conditional, I just got to make that an if statement, an if-then statement. So if, I'll just call it an angle. If an angle is a right angle, then it measures 90 degrees. And that's true. Oops. That's a true statement. But they look at the converse now. Remember, converse, I'm just flipping the order. So I'll say if an angle measures 90 degrees, oops, ugly, then it is a right angle. That's also true. If I got both of those are true, then my truth value of that whole biconditional is also going to be true. Why don't you guys try number 2, and we'll talk about that next class.